Everyone, myself Venu, lecturer in mechanical engineering from Government Polytechnic Varangal. So today our topic is vapor compression refrigeration system. If you observe in the previous video lessons, we have mostly seen the topics like air refrigeration. So we have discussed more the things on the air refrigeration and types of air refrigeration, open type and closed type air refrigeration. And next we have seen the analysis of Carnot cycle and Bell Coleman cycle. And here this VCR system, recent days or nowadays the most of the applications, if you observe, I think everyone knows all these applications like a refrigerator, a domestic refrigerator. You take a simple air conditioner or any cold storage, or for preserving some food items, or preserving some medicines, or preserving some vegetables, whatever it may be, where the cooling effect is required. So this system is adopting, and this vapor compression refrigeration system, so it is an advancement of air refrigeration. So we see, compared to the air refrigeration, so it gives out more the advantages, lot of advantages are there compared to the air refrigeration. So it is advancement of a air refrigeration, or it is the next model of a air refrigeration. But here the thing is, the if you observe the name itself, it will give some clarification like vapor compression refrigeration system. So whatever the refrigerant, I told that refrigerant is a heat carrying medium. So whatever the refrigerant is there, the refrigerant used in the system, it is in the form of a vapor. So that is compressed in the mechanical compressor we are using here. So the vapor in the form of a so vapor, the vapor form of refrigerant is compressed in the mechanical compressor. So the name itself gives like that, vapor compression refrigeration system. So further process will take place in the VCR system, and main components here also it includes, just like a air refrigeration, it also contains main components like the first one is compressor, condenser, the expansion valve, and fourth one is the evaporator. So in addition to that, it has some devices, or some safety devices, where to improve the efficiency or to improve the COP of the system, we are using that. And four main components are, so compressor, condenser, expansion valve and evaporator. Okay, so nowadays most of the applications are using this system, and let us see how it works and how the cooling effect is getting from by using this system. So it is getting very high COP and more the refrigeration effect, and compared to the cost also, the equipment, whatever the size of the equipment is also very less, cost is also very less. So lot of advantages are there. So we'll see it one by one. So just whatever discussed that last classes, some various methods of refrigeration. So it is also one method of refrigeration. Previous in our video classes we have seen some types of or some methods of refrigeration, like ice, dry ice refrigeration, steam jet refrigeration, and air refrigeration, and some liquid nitrogen refrigeration. So all these are the methods we are discussed in the previous video classes. It is another method of refrigeration, vapor compression refrigeration system. Okay, so we discussed a lot of things, and in the air refrigeration we have discussed that the Carnot cycle and Bell Coleman cycle, and they have made some analysis. They have done some problems on regarding these topics also. Okay, next coming to the today's class objective. So today we'll be able to learn, or able to know till end of the class, you can understood clearly about the principle regarding vapor compression refrigeration system, how it is getting work, how the cooling effect you are getting by using this system, what are the main components included in this. So all the things you can learn in this, the basic, the principle behind this you can learn, and learn about the parts, the main parts, the principal parts, and the functions of various parts. We will see one by one the function of each and every main component functioning, we will see regarding this. And also we'll see the applications of, so lot the starting I have discussed a lot of applications. We'll see the one by one application also of this vapor compression refrigeration system, right? This is regarding the objectives. So coming to the vapor compression refrigeration system, so it is based on, first we will see some basic principles. So it is based on some thermodynamic principles. So we will see the one by one. The fluid absorbs heat while changing from liquid phase to vapor phase. So whatever the fluid or some heat carrying medium we are using, that refrigerant, so that absorbs the heat while changing its phase. Whereas in the air refrigeration you cannot see the phase change, whereas in this you can see the phase change from changing from the liquid phase to the vapor phase. It means the vaporization process or evaporation process. You can see in the evaporator part. And next thing is the fluid rejects heat while changing its phase from the vapor to liquid. It means you can see the same thing at the whatever the refrigerant is flowing in the component. We take that is a condenser. For example, in the condenser it is flowing. So here the refrigerant heat is rejected to the surroundings and changes its phase from vapor phase to the liquid phase. It will convert to vapor refrigerant to the liquid refrigerant. Next, so other important thing is the phase change takes place at constant temperature. Next, the evaporation temperature or condensation temperature is dependent on pressure. Next principle is, as the pressure of the fluid increases, evaporation or condensation temperature increases. Next point, as the pressure of the fluid decreases, as vice versa, evaporation temperature, that means in the evaporator part and in the condenser part, so both the temperatures will also decreases as the pressure of the fluid decreases. So here you can see a simple diagram showing some components, like you can see just the first the compressor, and you can see at the right side the evaporator. So evaporator to the connection to the compressor, and to the compressor it making connection to the condenser, and to the condenser at the exit you can see it is making connection with the expansion valve, and from the expansion valve again it is making connection to the entry to the evaporator. So this is a closed cycle where the process continuing every time. So if you observe the right side of this compressor part, there is a evaporator. So where the color indication is different, it is having the refrigerant which is flowing inside this evaporator is the low pressure and low temperature. First it enters in the form of a liquid into the evaporator, and at the exit of the evaporator vapor will come outside with a low pressure and low temperature vapor. So that vapor form of refrigerant enters into the compressor, compression take place, and you can see at the left side of that compressor it will indicated with some orange color where the heat rejection is taking place in the condenser part. So after compression you can see the indication high pressure high temperature vapor is there. The next, after entering into the condenser, since it is maintaining with the constant pressure, high pressure and temperature, high temperature liquid, so the phase change is taking place in the condenser, vapor to liquid, by rejecting its heat. Whereas in the evaporator if you observe, absorbing the heat by the refrigerant which is flowing inside the system. And here the high temperature liquid which is entering through the expansion valve is expanded furtherly and reduces its pressure. So due to reduction of the pressure, as already seen the principle of the thermodynamic principle, due to the reduction of the pressure, temperature will also drop here. So very low temperatures are created at the expansion exit of the expansion valve. This is a simple system you can see. You can clearly understood in the line diagram. So we'll see some points regarding this principle of the VCRS system. As already explained, the principle of that VCRS system. So by the variation of the pressure of the fluid, The evaporation, condensation temperatures can be varied. So the pressure variations can be taken here. What happens, the temperature variations will also can be varied, so that the same system or the principle is used in VCR system. So a liquid, next one, a liquid which has very low boiling point is used as a refrigerant. So here mostly we are using some refrigerant. If you take some 10 years back like that, refrigerant mostly R12 like that. So dichloro-difluoromethane, it's a chemical name, R12, or in some other applications it may vary. So nowadays we are using R134A, or if you take in air conditioners, R22 like that. So different depends on different applications, different depends on the usage, depend on the purpose. The refrigerant or heat carrying medium used in that is a different case. So depending on the properties of the refrigerant we are using that. The most thing is where it has a low boiling point, it is used as a refrigerant in the VCR system. Next, if you observe, liquid refrigerant absorbs heat from the surface to be cooled and gets evaporated. The liquid refrigerant, so where it is entering into the evaporator from the expansion wall, and here the heat is absorbed by the refrigerant and it get evaporated. That evaporated refrigerant, it will enters into the compressor again. So that is in the form of gaseous state. And further what happens, compressor, due to its functioning, the pressure is increased. Next, so as the pressure increased, condensation temperature is also increased here. So right, as the pressure increased in the compressor with very high temperature, the condensation temperature which is entering into the condenser, the temperature is also increased. So this vapor is condensed at high temperature. So it is condensing back to the liquid in the condenser at very high temperatures. Right. Next, so using a condenser, the temperature of the liquid can be reduced at the same pressure. So what I have told, that at constant pressure, here what happening is the temperature of the liquid can be reduced. Okay, temperature variation can be seen. Condition is at the same pressure. That is happened in the condenser part. So here how it taking place means we will see further explanation of the each and every component function. Next, what happens, by reducing the pressure of the liquid, so evaporation of temperature is also reduced. It means reducing the pressure of the liquid, that happens in the expansion wall. So further reduction of the temperature take place, that is responsible for when it enters into the evaporator part due to heat exchange. So evaporation temperature is also reduced. Thus the liquid evaporates at low temperature, okay, which is present in the evaporator. The liquid which is having low temperatures, due to the heat exchange, so it will get evaporated. Right. So you can observe for some time here uh, what are the systems, the system what we are discussing. You can see the line diagram of a simple vapor compression refrigeration system. It will be very helpful. You can observe the line diagram. Okay, so see the components first. So starting from the, you can see the top one, the top chamber you can see here, it is the evaporator part. So in the evaporator you can see the pipeline where the refrigerant is flowing inside the pipeline. So it is a insulated cold chamber. Insulated cold chamber. Next, you can see inside pipes the refrigerant is flowing, and the pipe is making connection to the bottom. You can see where you can see at some point the pressure gauge is also is placed to measure the pressure. That pipeline is connected to the compressor part. Okay, so if you observe the compressor, it is making a inlet. First the inlet connection is coming from the evaporator part, and the exit of the compressor, if you observe, it is a high pressure side. High pressure side also we are placing one gauge, pressure gauge, and this exit of the compressor, the pipeline is making connection with the condenser part. It is a high pressure side. Okay, this pipeline is next making connection to the receiver. A receiver tank is placed. You can see it is making connection to the receiver tank. We will discuss the one by one what is the usage and functioning of the each and every component. Receiver, next if you observe the receiver, and from the receiver the pipeline is moving to the making connection to the next component, that is expansion valve or a refrigerant control valve or a capillary tube, whatever the name is, or thermostatic expansion valve, using number of names for that. Next, from the expansion valve you can see the pipeline is again connected to the evaporator part or insulated cold chamber. This is a closed cycle. So low pressure sides you can observe the top there is evaporator and expansion valve. At high pressure side you can observe the main two components are compressor and condenser. Low pressure side is evaporator and expansion valve. High pressure side is the compressor and condenser parts. Okay, so these are the main components. So first we will discuss the operations regarding the operations which are carried in four main components, that is in compressor, condenser, expansion valve and in evaporator. The main operations will carried is compression, condensation, expansion, evaporation. We'll see the one by one. Compression will take place in the compressor part, right? So first we list out the main operations what I have discussed here: compression, condensation, expansion and evaporation or vaporization. We'll see the one by one. The compression, see the points here. First you can see the entry to the compressor is from the pipeline is making connection from the evaporator part, it is entering into the compressor. So the first thing what you have discussed is in the evaporator what happens here, the evaporation will take place. It means again the heat absorption take place in the evaporator. That refrigerant is converted to the vapor form. So the vapor refrigerant is drawn from the first function of the compressor is it is drawn from the evaporator. So the low pressure low temperature vapor is drawn from evaporator and into the compressor. What happens in the compressor, it gets compressed and pressure and temperature of the refrigerant increases. So that is the function of the compression process. Pressure and temperature both simultaneously increases of particular vapor refrigerant which enters into the compressor. Next, see the next process, that is condensation. So here whatever the high pressure and high temperature vapor refrigerant which is coming from the, it will send to the next to the condenser part where the temperature of vapor refrigerant is drawn from the compressor, and here it will get cooled in the condenser. So here we are using some heat carrying medium or placing some fins or placing some high the fan will be placed whenever it is rotated. So the air will pass it onto the tubes, so heat exchange will take place. So here we are using air as a cooling medium. In some bigger applications or some bigger size of equipments we are using for condenser like water can be used as a heat exchange, making contact with the water, indirect contact. So the cooling will take place. The condition is at constant pressure. So the same pressure is maintained as the exit of the compressor, and in the condenser the pressure maintained is same. What happens here, due to the temperature, it means due to its cooling nature, the heat is rejected out to the surroundings. Backside of the condenser, if you observe, some heat is getting rejected. So due to this condition, it is maintaining high pressure, and the phase change will take place. The vapor refrigerant is converted to the liquid refrigerant in the condenser part. Next, since the pressure is high, condensation temperature is also high. So the refrigerant changes its phase from vapor to liquid. So this is a condensation process, condensing of refrigerant. at high temperature and at high pressures. Right. So here, so what I have told, that latent heat of condensation, it means no change of temperature, only the phase change will take place from vapor to liquid form. That is the condensation, latent heat of condensation, what I have discussed in the previous classes. Next process is expansion. We are using some equipment like a capillary tube. It is a type of expansion devices, capillary tube or TEX, thermostatic expansion valve. So these are the components used in the system, so depending on the application. So here what happens in the expansion valve is, expansion will take place, process is expansion. After condensation, liquid refrigerant is passed through the expansion valve. Since the pressure of the liquid refrigerant is reduced here in the expansion valve, more the pressure drop will take place here, and so the evaporation temperature is also decreases. Very low temperatures are created which will enters into the evaporator. The evaporator temperature, evaporation temperature also decreases. Right. Next, the final process will take place in the evaporator, that is vaporization. Liquid refrigerant with at low pressures and at low temperatures, which is coming from the expansion valve, is drawn into the evaporator. What happens, the liquid refrigerant is absorbs heat, so which is flowing inside the pipe. It absorbs the heat from the products which are placed inside the evaporator, and whatever the space to be cooled will absorb the heat from that. And here the liquid refrigerant changes its phase from liquid to vapor state. Since heat is removed from the space, or some products which are a substance are placed inside the evaporator, that heat is removed and that cooling effect is given to the products or substances or to the space, and the temperature of that space or the products will be reduced, and heat is removed from the particular products, and that heat is carried by the refrigerant which is flowing inside the evaporator pipes. What happens again, the phase change take place from liquid refrigerant to the vapor refrigerant. Again that low pressure vapor will enters into the compressor part. So this is a cycle repeating again and again. Okay. So how we are getting the cooling effect inside this evaporator? By using these four processes: compression, condensation, expansion and evaporation or vaporization process. Okay. The next right, continuation, vapor refrigerant coming out from the evaporator is at low temperature and low pressure. So already you have seen that. So this is sent to the compressor component. Okay. So hope you have understood the total system, the processes which are happening in the VCR system. Okay. Next, we'll see the parts explanation regarding the main components: compressor, condenser, expansion valve, evaporator, and in the same compressor. We'll see the one by one. Regarding the compressor, the compressor is the first part in the VCR system, and connecting to the compressor there is a discharge line. So discharge in the sense, you can see at the point from point B, it is discharging to the condenser part, making connection to the condenser. That is the discharge line. Next is the condenser. Next is the receiver tank. Condenser making contact with the receiver tank. Next to the receiver tank, it is a liquid line. So next to the liquid line, after receiver tank there is a liquid line. Through this liquid line, the liquid refrigerant will flow through this line, and next to that expansion valve is connected. Next to the expansion valve there is a connection to the evaporator, and again there is a suction line which is coming from the evaporator to compressor. This line is called as a suction line, where high pressure, you can take it as high pressure line also, where the high pressure low pressure line, low pressure side of that evaporator to compressor. So compressor, discharge line, condenser, receiver tank, liquid line, expansion valve, evaporator, and suction line. So all these are the components making a system vapor compression refrigeration system. We will discuss the component one by one. So first we will deal about with the function of the compressor. A round structure which is there here, you can see where the two ports are there. One is the inlet and outlet. Inlet is coming from the evaporator, the pipeline is connected, and next exit from the compressor, the pipeline is connected to the condenser. Here the compressor function is the low pressure refrigerant which is coming from the evaporator. In the vapor form, the vapor refrigerant enters into the compressor, and here it convert after compression will take place, and the high pressure vapor refrigerant is built up. That means high pressure and high temperature refrigerant is at the exit of the compressor, you can see with the help of a pressure gauge here. So that is the function of a compressor, and three things it will do. One, it will sucks the refrigerant from the evaporator, and second function is it will compresses the refrigerant in the compressor. Third thing is it delivers to the delivery side of a pipe to the condenser part. It delivers the refrigerant. So these are the three things, three functions by the compressor. So what happens here, the pressure and temperature increases. That is a function of all three functions of compressor. So next, coming to the discharge line. So after compression, high pressure and high temperature refrigerant which is after compressed, it will enters into the discharge line. So the line carrying the refrigerant from compressor outlet to condenser inlet is called discharge line. So this is a line you can see. You can see the high pressure recorded in the pressure gauges which is fixed in the discharge line or delivery line, right? The next component is the condenser, where after the delivery line you can see the high pressure where refrigerant which is entering into the condenser here. So it maintains the constant pressure here. What happens here, the vapor refrigerant changes its form or changes its phase from vapor refrigerant into the high pressure liquid refrigerant. At the end of the condenser you can see liquid refrigerant is coming outside. At the entry of the condenser you can see the vapor refrigerant with high pressure enters. So this is the how we are getting, just it acts like a condenser is nothing but acts like heat exchanger. So whenever with some cooling media that refrigerant is making indirect contact with that, heat exchange will take place, absorbs the heat from the vapor refrigerant by the cooling medium. They consider it as water. During its circulation it absorbs the heat from the vapor refrigerant. So heat rejection is taking place in the condenser. The refrigerant is giving out its heat to the surroundings or to the water or to the air. That is the function of the condenser. Just like it removes heat from the refrigerant at constant pressure. That is the condition. And here phase change will first occurs at the condenser part. Next, condition of the refrigerant coming out from the condenser is high pressure and low temperature. So we will see one condition, at the exit of the compressor it is high pressure and high temperature vapor. At exit of the condenser, if you observe, it is high pressure and low temperature liquid. Phase is changed here. Next, after from the condenser, next you see it will enters into the receiver tank. A very simple function of a receiver tank is it will stores the liquid refrigerant that is coming from the condenser. Just it will stores the liquid refrigerant. After from the condenser, directly it will collect in the receiver tank, and it supplies the refrigerant to the evaporator through the expansion valve. There is a in between component, expansion valve is there. So it will supply the refrigerant through the expansion valve next to the evaporator. So depending on the requirement, if more the load is there in the evaporator part, it will receive the more refrigerant. So depending on the load variations, the receiver the liquid refrigerant is sent through the expansion device. Next, observe the liquid line, the line which is carrying the liquid refrigerant from the condenser outlet to the evaporator inlet. Up to the evaporator inlet, the line is a liquid line. Next, this is a liquid line. So in between the liquid line you can see the expansion valve. So the function of this expansion valve is, whatever the high pressure liquid which is entering into the expansion valve, it reduces the high pressure liquid to low pressure liquid refrigerant. So where the high pressure drop will take place, the temperature drop will also takes place rapidly at this point. So condition of the refrigerant coming out from the expansion valve is low pressure, low temperature liquid. Function of expansion valve, it reduces the, as earlier discussed, at a high pressure liquid refrigerant to convert it to the low pressure refrigerant. So what happens here, due to reduction of the pressure, high pressure to low pressure, the liquid refrigerant, the temperature will also reduce drastically. Very rapid decrease in the temperature will take place. So low temperatures are created, which will be get which will next enter into the evaporator part. The condition of the refrigerant here, as earlier discussed, which is coming out from the expansion valve, is low pressure, low temperature liquid. So before that, if you observe, it has a high pressure, low temperature liquid. And further, after expansion, what happens? Low pressure and low temperature, very low temperatures are created. That liquid refrigerant is come out of the expansion valve, next enter into the evaporator. So we'll see the function of evaporator. So the upper part, if you see, it's a insulated cold chamber. You can see no heat can be, it has to go outside, no heat should be added inside the chamber. So it must and should be, it should be insulated one. So here if you observe insulation, most of the refrigerators, there is some glass wool type of structures, some thermocol or some other material, insulated material will be placed inside the evaporator box. So no heat will be added or rejected here. So from outside surroundings to inside, there will be no contact or no heat exchange will take place. So here inside the component, if you observe, there will be a pipeline system will be there, and inside the cold chamber you can place any products, or the space can be cooled inside that by absorbing the heat by the refrigerant. So here the function of evaporator, the liquid refrigerant in the evaporator absorbs heat from the products and changes its state from liquid to vapor. So the liquid refrigerant is entering into the evaporator due to the heat exchange between the products and the refrigerant, liquid refrigerant. Here the phase change will occurs. This is the second place where the phase change is taking place. First, in the condenser, condensation is happening from vapor to liquid, and in the evaporator it is the reverse of that. Vaporization is taking place. That means liquid refrigerant is converting to the vapor refrigerant. So it is again the latent heat of vaporization is taking place in the evaporator, whereas in the condenser, latent heat of condensation is taking place. So here we are getting the cooling effect in the evaporator. That's nothing but refrigeration effect produces in the evaporator. So the product stored in the evaporator gets cooled as the heat is removed from the products by the refrigerant which is flowing inside the tubes. So finally what happens, the refrigerant will next that vaporized refrigerant will, the low pressure and low temperature refrigerant, next it enters into the suction line. Just after the evaporator will enters into the pipeline. So the pipeline carrying the refrigerant from the evaporator outlet to the inlet of the compressor or up to the suction valve of the compressor. You can see a pressure gauge will be produced here to measure the pressure in the suction line. So this is a suction line connecting evaporator and compressor, where it carries the low pressure vapor. So all these are the main components of and more additional components of a VCR system, vapor compression refrigeration systems. Okay, so this is regarding the explanation of the different system processes happening in the VCR, like in the compressor component, compression, and in the condenser component, having condensation, and in the expander or in some expansion valve, the expansion process is taking place, and in the evaporator, vaporization process or evaporation process is taking place, right? So all these are the explanation regarding VCR system, and hope you have understood how you are getting the cooling effect in this case. And next, if you observe the applications of VCR system, so here the applications, if you observe, there is a starting of the class we have seen some like most of this VCR system is used in number of applications, just like I told, like refrigerators, how the household or domestic refrigerators are there. Most of the every household is having the refrigerator, most of 90%. So they are using these refrigerators. The same system is adopted in that vapor compression refrigeration system. And if you see the water coolers, where the purpose of water cooler is to cool the water for drinking purpose. And like commercial applications like ice plants and cold storages. So to produce the ice cubes, we are using the ice plants, and cold storages for storing for the larger equipment or some other food products. Larger quantity of food products can be stored in the cold storages. So for this also, maintaining low temperatures, so this system is adopted, VCR system. Next, like comfort applications, just like our home or some any industries inside that, to maintain some comfort conditions, it means comfort temperatures. The air conditioning units are used, different types of air conditioning units. So all the units may be working on this system, vapor compression refrigeration system. So utilizing all the same components and same processes happened in that. So preservation of medicines, it is also an application. It's a very important application. And you can see some diagrammatic applications here, like domestic refrigerator. I think you know this case, storing all the food products inside that, maintain low in temperature, and it can be stored for a longer period. So food preservation technique it is. Next, you know about the water cooler. This is a mini water cooler used for drinking, cooling the water. And in this also VCR system is there, where it is consisting of all those main components, just used for cooling the water up to a particular temperature. It is also one type of water cooler. Next, you see, just like in some where the food items are arranged in some areas to store the food, or to sell these cold and fresh products of the food. So it can be stored like in a refrigerator spaces like this, where they are providing some refrigeration effect through these areas. Okay. And this is some cold storage units. So inside that, so we can place any other products to be kept for longer period, and it can be stored as cold at a particular temperature. These are the cold storage units. It's also cold storage units. And you know well about these window air conditioners. So it is a one type of air conditioner. Okay, window type, where it is fixed to the window. So this is also runs on the same VCR system. It is also one application. And nowadays we are using this split type air conditioner, having a different indoor and outdoor units. So fixed at indoor, and some components are fixed where the temperature producing units like compressor and condenser, they may be placed at the outside, or those are the outdoor units. Split air conditioner is also an application. Okay. So just we summarize all the topics. Just mostly we have seen some principles, the thermodynamic principles involved in the vapor compression refrigeration system. How the pressure and temperatures are varying, how the cooling effect you are getting, what are the thermodynamic principle behind that, and what is the principle of a VCR system. And we have seen some sequence of operations: compression, condensation, expansion, and evaporation taking place in different components in the VCR system. And explain the different parts, main components, and their functioning. And we have seen the applications also, a lot of applications. The recent all the cooling equipments what are there, mostly they are working on vapor compression refrigeration systems, because of its higher performance, higher coefficient of performance, higher refrigeration effect. Okay. So let us have a small questions on this quiz. So application, asking application of VCR system is, you can see here, All these are the applications on the domestic refrigerator, water cooler, air conditioner. So the answer you can place it is all of the above is the answer, right? Okay, next, second question. A compressor is located between, it means we have seen the connection, a sequence of connection of the parts, and it is asking where the compressor is located between. If you observe the options here, so is it located between evaporator and condenser, or in between condenser and evaporator, or in between expansion valve and compressor, and in between compressor and expansion valve? So he's asking directly. The compressor is located between. So before the compressor you can see the evaporator, then next after the compressor you can see the condenser. So it is placed in between evaporator and condenser. The answer is A. Okay, right. See the next question. Condenser is located between. Again the same question. So before the condenser, if you observe, there is a compressor. Next after the condenser, what is the component we have? Like expansion valve, right? You can see that. So here we have answer is the compressor and expansion valve. All the options are given. You know that condenser is placed in between the compressor and the expansion valve. Next question. Expansion valve is located between. Again the same way. Before the expansion valve we have the condenser, right? And next to the expansion valve, after the expansion valve, it is moving into the connection is moving into the evaporator. So in between the condenser and in between the condenser and the evaporator, the component placed is the expansion valve. Okay, so the answer is condenser and evaporator, that is B. Right. Next question is evaporator is located between. Again the same series of connection, if you observe, before the evaporator there is expansion valve. After the evaporator, if you observe, that is next to the evaporator, the pipeline is going into the condenser, the compressor. So expansion valve and compressor. So you can see the third option, expansion valve and compressor is the answer. Or you can is located between expansion valve and compressor, whatever it may be, the answer is right. Maybe compressor and expansion valve. So these are the frequently asked questions. So draw the line diagram of simple vapor compression refrigeration system and indicate all the parts in it. Let's explain the working of a simple VCRS system with a line diagram. Next, same, list out the various parts of a simple VCRS system and explain the function of each component. Okay, these are the few questions. And next, write at least 4 applications of VCRS system. It's like domestic refrigerator, water cooler, ice plant, cold storage unit, air conditioners. All these are the applications of the VCRS system. Okay, so hope you have understood this video lesson, and this is very, I think, very clear. You have understood the vapor compression refrigeration system and how you are getting the cooling effect by using all these important components and the refrigerant inside the system, that is a heat carrying medium, how it is getting the phase changes are taking place in the condenser and in the evaporator, and uh, what is how the what component it is made in constant pressure process is taking place, and what happens in the compression, after compression what is happening to the refrigerant. That each and every component we have seen the different processes, every processes. Okay, so this is regarding vapor compression refrigeration system. So we have understood.